In this video, I'm going to tell you the truth about AI agents. Now, contrary to what the marketers try to make you think, we haven't yet achieved fully autonomous AI systems or AI agents as of yet in January 2025. The road to achieving AI agents is still a work in progress, and we still have certain barriers and limitations that we have to overcome in order to achieve fully agentic systems that are usable in practice. In this video, I'm going to take you through exactly what these limitations and risks are, and I'm also going to tell you how I think we're going to be able to overcome them on the road to achieving AI agents in 2025. So without further ado, let's get right into it. All right, so I wanted to start with this little meme here that says, when someone is telling you a story and you know that they're lying. I'm not saying that people are lying, but I think what I really want to emphasize is that honestly, in 2025 and even in 2024 and 2023, it's been like this for a couple of years. Anything that happens in the AI space, you should take with a grain of salt, because there seems to be a lot of hype and a lot of marketing around AI stuff. So me personally, every time I read a piece of AI news or I watch someone's ad for their AI app, I always sit down and I'm like, does that make sense? Like, are we currently there in terms of technology capabilities? If yes, then happy days. But a lot of the times, the answer is actually no. And you should try and train yourself to be able to read through the bullshit. Now, I'm not saying AI agents are bullshit. As I said before, I think they're absolutely amazing and they're revolutionary. But there is definitely certain things about them that we have not been able to fully conquer yet. And in this video, I'm going to go through exactly that. So when it comes to AI agents, there's really 4 core limitations currently. First one, cost. Second one, precision or accuracy. Third one, privacy. And fourth one, the risk of total doom. I'll get into each of these one by one. So cost is the first limitation of AI agents. Large language models in AI agents need to have very long context windows for memory, and so they quite often end up being pretty expensive. Now, if you think about an AI agent, let's say an AI agent usually has to perform a whole bunch of different tasks in order for it to be able to achieve the complex objective that you gave it. And since it has to do so many things, it would have to maintain memory of a lot of data during that process. Like, for example, it would have to remember who it is. It would have to remember what the overall objective or the overall goal is. It would have to remember what previously happened. It would have to remember its thoughts, because let's say, for example, if I'm sitting down and I'm trying to think about solving a problem, if I can't remember what I just thought about 2 seconds ago, that means I have a mind blank, right? It means I have to start from scratch. Same thing with AI agents. They have to be able to remember what they were thinking about in order for them to be able to progress. And this sort of memory ends up what it ends up looking like in practice is the context window of the large language model as it progresses through the workflow. Basically, in simple terms, what that means is just there's a lot more input into the large language model because it has to remember a whole bunch of things. And since there's a lot more input, there's a lot more tokens. And since there's a lot more tokens, running the LLMs is going to be a lot more expensive. Now, especially the bigger and bigger this workflow gets, the more things the AI agent has to remember, and the more expensive running the AI agent will end up being. Expensiveness or cost is definitely one issue, but I do think that this is going to be solved quite soon with cheaper models. So at the moment, all of the foundational model sort of companies are trying to build models that have higher context windows so that the LLM can remember more and more things that are also cheaper, so that when it's remembering all these things, it's not costing an arm and a leg, right? So this is going to be solved with cheaper models that have higher context windows, which is exactly the direction that we're currently going in. And I think that in the very short term, this problem is going to be solved, or at least largely solved. Now, the second limitation of AI agents, which is also very important, is the precision limitation, or I like to call it the error rate limitation, right? Let's think of this one like this. So let's say, for example, if you go to ChatGPT again, and what I'm drawing here is just the interface of ChatGPT, and you write in some sort of prompt and you get some sort of answer as the output, right? Let's say if ChatGPT itself had and 95% accuracy, meaning that out of every 100 answers that it gives you, 95 of them are correct and only 5 of them are incorrect. That's a pretty good accuracy, right? Because you're likely not going to write the same thing 100 times in a row. And even if you do, if it's only going to come back like wrong 5 out of 100 times, then it's not a big deal, right? The difference when it comes to AI agents, however, is, as I said, an AI agent's basically workflow, the workflow that the AI agent creates in order to be able to complete the task is probably going to be quite large, right? Let's just say all of these different subtasks are being completed, and in each of these subtasks, the LLM has to have some sort of input, and it would do a certain thing in order for the basically the workflow to progress further, right? What happens is, let's say, for example, if we use an LLM again that has a 95% accuracy, what happens is the first module would come back right 95% of the time. So 95 out of 100 times, the first module is going to be correct. Then the second module is also going to be correct 95 out of 100 times. Then the third module is also going to be correct 95 out of 100 times. Then the fourth module also 95 out of 100 times, and so on and so forth, right? The overall accuracy of the model then is not equal to 95%. It's actually equal to 95% to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Or basically to the power of the number of times the LLM has to give you some sort of output, right? So 95% to the power of 10 is, let me just figure out what that is.
One eternity later.
That's about 60%. So so the model itself, the large language model or the reasoning model or the brain behind the agent is 95% accurate, but when it goes into a big complex workflow with 10 sort of outputs or 10 different modules, the accuracy goes from 95% down to 60%. Now, 95% in practice, like in business use case, you probably could sort of get away with it. You probably still wouldn't, because you'd want to have like 99% accuracy in a real industry sort of scenario. But 60% is something that you definitely can't use in a real business use case, especially if it's high stakes. If it's low stakes, if it's like write an SEO post, it doesn't matter. If it's like send out, I don't know, like a pretty standard newsletter, doesn't matter. But if it's something that it's like a super complex workflow for like a really high stakes business and the accuracy is 60%, then that's horrendous. Like no one's going to want to pay for that. So the precision is also another problem when it comes to AI agents' current capabilities. Now, I do believe that this could be fixed as models become more and more accurate over time and become better and better performing. This issue of error rate would also go away or become smaller and smaller. Because if you have, for example, a model that's giving you the same output, that's not the right way to write it. If you have a model that's giving you the same output 99% of the time, or it's giving you the correct output 99% of the time, 99 to the power of 10 is going to be much higher than 95 to the power of 10, right? And if it then increases to, what am I writing? 99999 accuracy, meaning that it gives you the wrong answer 1 out of every 10,000 times, then that accuracy would also be a lot higher, if that kind of makes sense. So yeah, the idea is to make the models better, and if we make the models better, we move closer to AI agents, which is also happening. Like the O3 model that's coming out is definitely going to push us a lot further to that goal. So the next problem or the next limitation is kind of more of a qualitative limitation, and this is the privacy limitation. I probably wouldn't call this a limitation. I would call this more of a risk, a privacy risk. So as you guys know, the definition of an AI agent is a fully autonomous system that can interact with its environment in order to achieve objectives. So the system has to be fully autonomous for it to be a fully acceptable AI agent, right? And what fully autonomous means is you kind of have this AI agent sitting here That's like a brain inside a box. This is the AI agent. And you tell the AI agent to do something, and then the AI agent goes and does that thing fully by itself, right? It doesn't ask you for any sort of permission to do anything. It doesn't ask you how it should go and do a certain thing. You just tell it what you want it to do, and it goes and does that by itself with full autonomy, right? Now, in a business use case, this is great because you don't have to have someone that's going to sit there 24/7 and make sure the AI agent is right and is doing its job correctly and approve of everything. You just kind of leave it there and it does everything for you, which is really good in terms of efficiency. But this does kind of expose the business to a certain level of privacy risk. And the reason for that is a lot of the times businesses would have to give these AI agents a lot of their proprietary data in order to train them to perform the way that they want them to perform. So the business has all of this data that they've been keeping, that they've accumulated over time. That's very important. And they've given the AI agent access to this data so the AI agent knows exactly what it's meant to do and how it's meant to achieve that certain thing, right? Now, giving this model full autonomy, you kind of like you're counting on the fact that this model isn't going to go and do something that's going to potentially expose the proprietary data you gave it somewhere to like a malicious sort of, I don't know, malware or something online, right? So you're kind of trusting the AI agent with the data that you gave it. Now, this is, as I said, more of a risk. And you can always try and mitigate risk. So I think the solution here is just to have someone that knows what they're doing so they can implement the AI agent properly, and obviously put the correct guidelines and like roadblocks in place in order to ensure that the AI agent isn't going to expose any sort of proprietary data. But this risk is a risk that you do kind of have to bear because you are giving the model full autonomy, right? So privacy risk is one, but it could be mitigated to a very small risk. Now, the next biggest risk, which is the one that everyone likes to talk about, is the doom risk, or the risk of the extinction of humanity. And I think the easiest way to explain this, again, is just with an analogy, right? The main keywords here, though, just before I do give you the analogy, is fully autonomous. Like, it's the same scenario. You're trusting an AI agent to do a certain thing with full autonomy. The analogy here that a lot of people like to talk about is, okay, well, what if we tell an AI agent to go and solve world hunger? Like, basically, you tell the AI agent, go and solve world hunger, right? And the AI agent sits there and thinks and is like, okay, solve world hunger. How can I do this? Potentially I can do this. Potentially I can do that, or do this, or do this. First I'll do this, then I'll do this, then I'll do this. And then eventually the AI agent decides that, okay, the only way to solve world hunger is to get rid of the entire human population, right? It's like, okay, well, there's no other way for me to achieve this. The only way to do it is to kill everyone, right? And this is kind of what some people worry about. Giving AI agents full autonomy in order for them to achieve objectives is quite dangerous because you're kind of trusting that this agent is going to still do something that's in line with ethics, right? And it's in line with like safety. And so, yeah, so this is like it's a pretty, I would say it's a pretty big risk. Especially if we build very capable agentic systems that have full autonomy and aren't very well guardrailed. It is quite a big risk. And I think realistically, like, the two main ways that you can try and mitigate this risk, this is also not a limitation, as I said, it's a risk, is number one, with regulation. Like, obviously governments can come and put regulations in place that basically stop, for example, AI agents from having certain capabilities or achieving a certain level of full autonomy. And another way that we can also do this, and I'm not really sure how feasible this is in practice, but I have heard researchers say that they can add some sort of kill switch. Now, I don't know what that really entitles, but I would assume it's like, I don't know, like a button or something, you press it and the AI agent just stops working altogether. So yeah, the doom risk is also an interesting one, a bit of a fictional one, but it's definitely a risk that is there. Cool. So cost, error rate, privacy, and total doom is probably the four main like limitations / risks that AI agents are currently facing. But there is also a certain level of pushback and limitation from the user end as opposed to the developer end as well currently when it comes to AI agents. And these three are resistance to new technology, lack of training data, and job displacement. So by resistance to new tech, what I mean is if you guys look at, for example, the tech adoption life cycle, generally how it works is there's always a certain amount of resistance from people before they actually take on a new technology. And this is mainly just because of the lack of understanding of the transformational effects of that technology and also the lack of trust towards new tech, right? Especially from like small and medium-sized business owners. So there is always that certain level of pushback when a new tech comes out. And AI has been facing that pushback for quite some time now. Like I've been working in the automation space and I've definitely seen firsthand that a lot of people are still quite skeptical to AI. And I'm sure that when AI agents become commercially viable, people are still going to be quite skeptical. So there is going to be that sort of initial resistance to onboarding AI agents, but I don't think this resistance is going to last forever. What I always like to say and what I always like to think is, okay, let's say if we have, let's say, for example, the cafe industry sector, I don't know what to call it, right? And inside the cafe industry, there is 5 cafes, right? If only one of these cafes is implementing AI and reducing the cost of their coffee from $100 to $80, that's not a big deal, right? Because yeah, they can charge a lower amount and they probably get some of the customers from these other cafes. But if the second cafe sees, okay, well, this person's doing well with AI agents and they've reduced their cost and they also reduce their cost, and then this person also reduces their cost. Now, 3 out of 5 people in the industry have a much lower cost of goods sold, and so their margins are higher, so they can charge less, right? And since they are now able to charge less, these 2 people would have to also implement AI agents or whatever that technology was in order for them to be able to compete. So whether these last 2 people like it or not, if they want to stay in the game and they don't want to completely lose, they have to also adopt this technology. So how it kind of always looks like is this sort of bell curve. Like, over here is the sort of innovators, and then the early adopters, and then the majority, and then the late majority. And then these are just the people that kind of die out, right? So innovators is the first person that reduces their cost of goods sold by taking on the new technology, and they're taking a certain amount of risk. And then these early adopters are like, oh, okay, shit, like this is a pretty cool technology. Let us invest in it as well. So these are probably the next like 1 person that comes in. The majority is then like, let's say, for example, these 2 people, they're like, okay, well, everyone else is doing it. We probably have to do it as well. And then later, this person's going to come in and be like, okay, well, everyone else has done it. I also have to do it. And then if there is another cafe that just doesn't adopt the technology, they're just going to die out, right? So realistically, eventually everyone is going to have to onboard this technology because it's going to be revolutionary. But there is always going to be that sort of initial resistance to the new tech. So that's the first one. So the second one is the lack of training data. And basically what I just mean here is like AI agents are going to need proprietary data in order for them to be able to operate optimally. Let's say if you want to implement AI agents in any sort of vertical, let's say vertical. Let's say the compliance vertical, for example. You want to implement an AI agent to be able to do something in the compliance space. You would have to train that AI agent on proprietary data so that it would know what it's meant to do in each scenario. It's not just like super smart and it knows everything about everything and you don't need to tell it anything. You'd need to train it on some sort of like vertical or niche data for it to perform better in like completing certain tasks within that vertical. And a lot of smaller businesses just don't have access to that sort of data. And that's why the smaller businesses are going to find it a little bit harder to implement fully autonomous and also sort of highly accurate AI agents into their business. Now, the third problem is just a problem of job displacement. Obviously, as AI agents come in, they're going to displace a lot of jobs, because if you have a system that's able to complete tasks with full autonomy, and if it's also able to complete a lot of diverse tasks, not just a very narrow set of tasks, that's basically just the definition of an employee. So in the future, there is going to be a big marketplace for AI employees, which is, let's just say, AI agents that you can hire as an employee at a fraction of the cost of an employee. And what this is realistically going to mean probably is the loss of a lot of jobs. And I think there is definitely going to be, or I hope there is going to be, some sort of guardrails set in place or regulations set in place by the government that's going to ensure that this doesn't happen, or at least if it does happen, it gets replaced with certain other jobs to obviously keep the economy going. But this is definitely a risk that we're all facing by onboarding fully autonomous AI agents. So job displacement is going to be huge in the future, and it's going to be quite interesting to see how it all plays out. Cool. So that was the limitations of AI agents. I hope you guys enjoyed this video. Feel free to leave a comment as to what I should talk about next. And also don't forget to like and subscribe, and I will see you in the next video. Cheers.